skills, but I know nothing really about 3D graphics. I do economics and some Android and mobile stuff. But when you look at the kind of information on the internet about doing three-dimensional graphics, it's always claimed to be an advanced thing. It's something only for the experts, only for the really skilled people. I don't think this is true. So if I can manage it, so can you. So on the left, here is OpenGL. This is one of the simplest OpenGL programs I could find. It draws a single gray line, and it's hideous. It involves lots of hideous C code. Yeah. On the right, here it is in processing. It is so much simpler. There are two methods you implement in a Java-like language. Java without some unnecessary prep. You just write the global command to draw the thing you want. That's all there is. There are these two methods, set up and draw. But if you want to add interactivity, you just override some of these other methods. So mouse click, mouse drag, key press, and it works in a very simple way. There's no figuring out the ASCII code of a letter in your keyboard. It's, was this letter B, A, the normal keys in your keyboard. You can look at the position of the mouse, the last known position of the mouse and keys, and so on. Okay, so a lot of the introductions to processing, they all start with 2 dimensions, because that's easier. The 3 dimensions is not much harder. It's only like twice as hard. It's the 3 dimensions is just 2 lots of 2 dimensions, kind of. A little bit of school trigonometry and this Java-like stuff. Here is your space you're working. Anything you can imagine you can draw. Just draw spheres, cubes, using these very simple global commands. No messy around. You can add lighting in a really simple way. Here is this like simple code I found, which draws this. It's hard to see in 2 dimensions because obviously this interacts with the mouse. So based on the mouse position, we rotate these cubes. We add a couple of lights. This looks beautiful, and it's barely any code. It's really simple. You can do this. Here's something simple I wrote, which again you can't really see in 2 dimensions. But based on the mouse position, you add energy to this sort of field of these like boxes, and you see these waves quite pretty. It looks quite pretty. Again, in 2 dimensions you can't really see it, but it's really, really simple. Like it's a few lines of code. It's much easier than all the hacks you're probably working on. Well, a lot easier. So there's some things I didn't cover, but processing has really sensible defaults. So it gives you a sensible default camera, and you don't really need to worry about textures. You can add pretty material properties, the shininess and so on of the materials. You can add lightings, you can add point lightings, background lightings, and so on. And it's all nicely documented online. There are lots of examples that come with the program. Here's the sort of list of folders. Each of these folders, there will be a bunch of examples. For anything you can imagine, there will be an example which will make it clear what you need to do. And it's usually very, very simple. One of the other nice things about processing is that you can very easily deploy it to the web, so using WebGL, so you can do 3D graphics on the web, and to Android. You can do 3D stuff in Android, you can do multi-touch stuff. You can use the camera, you can do really incredible stuff. Yeah, that's a quick look at. There are some books I recommend. The one on the left is this nice cookbook which gives lots of examples. One of the things I really like about this book is that in the 3rd chapter of about 10, it talks about 3D. 3D is something that you should learn about. It's not something to be ignored, like in the other little getting started with processing book, where 3D is a scary advanced topic. It's really easy. Look at the examples. The book on the right, by the way, is it's my favorite book probably about processing, but it's quite expensive, but it's filled with beautiful examples, and I highly recommend it. Here are some links. I will put these online, so if you follow me on Twitter or Google this afterwards, you will find details. There's lots of great stuff online. There's some websites you can use to actually edit code online and run it online using the HTML5 version of processing. So thank you. Yeah, follow me on Twitter and give me details and stuff. Thanks. Thank you. So just before I announce the next speaker, Dan Coresi, are you around here? No, does anybody have a nice camera that they can record this with? Because I can't find my camera now.
That's recording already, so.
No, that's recording. Cool, thank you. So the next speaker that we have is Musasha Lakhani talking about innovation in sport equipment. Hello, good evening.
I'm going to be talking to you about innovation in
This is actually one of my favorite innovations. It was in 1954, West Germany versus Hungary, Football World Cup final. A really, really wet condition. West Germany, the underdogs, won. Why? They had shoes with exchangeable screw-in studs. They put in the longer studs for the wetter environment, and you have Adidas by Adidas Runner. Think about adaptability. User-driven innovation. Skis were totally spineless. It resulted in an 86% drop in tibia fractures. It was user-driven. If some guy sitting in a hospital with a broken foot thought, hang on, I can do this. Game changers. Can you imagine? Table tennis, you played with rubber balls. The injuries, balls probably flying around in your living room. The celluloid spare added finesse. Of course, boys will be boys. The greatest Ferrari, I reckon, is the F2004. Schumacher's last championship winning car. Won everything. Anyone disagrees? No. Right. Rubber suits. It was launched at Beijing Olympics. Everyone was wearing it. All the races were being won by people wearing this suit. 98% of the medals were won by people using this. Is this technological doping? Was banned a couple of years later. It must be. This is actually quite an interesting. Blade Runner, carbon fiber prosthetics. It's almost as if you've got inclusive Olympics. Right now, he hasn't won anything. Wait till he does. But you've got to know your industry as well, you know. These APL shoes, the concept one, was launched, and they tested, on average, 3.5-inch increase in your jump. That's amazing, right? In the NBA, it was banned. Why? Not launched by one of the big boys. And obviously, this is the future. You've got cameras recording everything, all form of real-time and interactive feedback. And I suppose this is where the majority of the future innovations will come from. So I ask you this: the age-old argument, the purists, the traditionalists, simply thinks that sport was better in the older day. It was much more rugged, much more tougher. So have we reached our optimum in terms of innovation? Our future generations won't think so. Stifling of innovation. Where do we draw the line? Where does it become man versus machine, machine versus machine, a combination versus a combination? Who decides where to draw the line in innovation? Obviously, global standardization is important, but cost is also important. I mean, something very small as goal line technology, using a small sensor, can't be implemented because it can't be standardized across the world. So I leave you with a very simple debate. Is sport essentially a competition of the athlete or the engineer? You decide. Your comments on hacking sport, obviously you can follow me to talk about anything sport or any of the cool ideas that I've seen. Any questions that you might have, please get in touch. Thank you.
I just want to say thank you to our speakers, because for some of them, this is absolutely the first time they've ever done this. If you're standing on a stage like this, light shining in your face, I think even Justin Bieber would shit his pants. Next up is Elena Alvarez, who's going to talk about give me an API and I shall move the earth.
Hi everyone. I'm here to talk about APIs, unsurprisingly, but here to talk about APIs from a slightly different perspective that I've seen. Lately, I've been to some events and conferences on APIs, and they are always, or they tend to be aimed either to a technical audience, like professional developers, either from a business point of view, you know, the guys in the ties. And I think there's a third group of API users and people interested in APIs that are not in this group. And is the amateur developer that is not a professional developer, they don't work on that, they just perhaps learning to code and that enjoy doing stuff on their spare time and on their own. And as I say, I'm one of these type of API enthusiasts, I would say. I'm not a professional developer, so Why I think this profile is interesting? Well, I've been coding for a short time, and I'm very happy. I'm very proud of what I do, even when are small things. But I tend to encounter a situation similar to this one over here. A situation in which I have ideas, I know what I want to do, but what I want to do is beyond my skills. It's beyond what I can do, and I don't have the skills to do it. I don't have the time to do it because I'm not professional. So it's very frustrating not to continue doing something you know it would be very interesting to do. And in this moment, and for this type of amateur developer, APIs are a very good solution. Why? Because they will allow you to come over this situation you cannot solve in a very easy way. You just need to call an API, grab the information you need, and then the problem is solved. So APIs will solve your problems. They will make you fly or turn it into a raccoon or a penguin or whatever you need to be turned into. And the thing is, APIs are getting so popular these days, and it's great because we have almost all flavors of APIs. If you have trouble, if what you need is something to send emails, to make phone calls, to get any sort of information, you'll find an API that provides that sort of information. So it's great because this means that you have help, that you can solve almost any problem that you face. For me, the metaphor with Super Mario and APIs doesn't stop there because for me, when I'm using APIs, I feel a bit like I'm doing plumbing because I take something and I send it to an API and I get the result and then I use another API and I connect it to another API, so you end up making something totally different just by connecting one. It's a bit like plumbing. And one of the things I discovered that is with this type of people that we're not professional developers, that we come from other areas, is that sometimes because you come from other areas, that could be something good because you might have an idea of things to do with an API that no one has thought about before. Because you come from different areas, so you have other views. Me, for instance, I come from the humanities. I'm a linguist, so my job is studying how languages work. And with my colleagues and I we have discovered that using APIs we could create great resources. And for instance, this is a dictionary that we made. And can you imagine the joy of a linguist building their own dictionary? Because dictionaries take a lot of time to be built, sometimes decades. And this was far beyond what I could do. This was technologically way too complicated, and we didn't have the resources to do it. But just grabbing APIs from different places and put them all together, we did our own dictionary. We did something great for us. In this case, we used APIs in apiculture, disclosure. I'm part of the apiculture team, but there are many other examples of platforms and companies and startups that are aiming at this type of amateur developer. Before this, in one of the workshops, we were talking about Aperigan.io, which is a platform for building apps. There are some other examples, like using the APIs in learning, which are also great. So the message is for people who are starting, just get APIs because they will help you a lot. And for the companies, not even just at the Jedi, they will be the ones that build big things, but also think about the Padawans that are coding, because I'm sure that they will be able to do great things, make life easier for them, and in the end, I'm sure that they will surprise with what they'll build. That's all. Thank you very much.
Thank you very much for that. That was pretty good. I like that. Next up is, yeah, you can use that microphone. Next up is Steve. Steve Goodwin, he's going to talk about 101 ideas in home automation.
Yeah. Oh, hello. Right, so somewhere on here there should be my first slide. Do we have my slides? There we go. So, as that part of the slide says, my name is Stephen Goodwin, and as that part of the slide says, 101 ideas in home automation. Or at least as many as I can get through in the next 4 minutes and 49 seconds. So, what do I mean by home automation? Well, we'll start with a pithy phrase. Home automation is anything your house does for you to make living there more interesting, enjoyable, or productive. Lots of things: appliance control, switching lights on and off. You've probably all seen Hue that does this sort of thing. controlling media systems, that's another element of it as well. It's more about how you put these individual units together to make something bigger than the units themselves. So this is appliance control. I use X10 as well as Hue, so this is the X10 example. The machine on the left plugs into the USB port of your computer and into the power line. Your computer sends a message, it puts it on the power line. This is then picked up by the machine in the middle. If it sees the message on the power line, it looks like it's addressed to it, it then switches on whatever is plugged into it, like a lamp or a kettle. So, you have to code it. I use Minerva because it's brilliant and I wrote it. You might detect a bias. So, what you do, you say, I would like to switch on the light. I would like to turn my lamp into red. I want to switch it to blue, for example. All possible, all very scriptable. Which means I actually have a script called kettle that switches on the kettle, waits for 75 seconds, which is how long my kettle takes to boil. It then uses a speech synthesis program to say the kettle has boiled, and then switches the kettle off. 4 lines of code. It's not difficult to have a remote control kettle. Media playback is another very common use for home automation. It's now so easy to build your own Myth TV box, hook up a Raspberry Pi. It's better than your box standard buy it from Dixon's kind of PVR, because this means you can SSH into it from work. If you're sat around the corner and someone's saying, that program's on tonight, it's going to be really good, if you forgot to set it, doesn't matter. Shell it, set it to record. Simple. Video didn't quite kill the radio star. Voice is actually one of my most used features. Basically, what it allows you to do is, quite obviously, listen to the output of your house rather than having to watch it. Which means you can either say, I will pre-record lots and lots of voice samples and piece them together like train announcements do, or I can use Festival, which will allow an arbitrary amount of text to be spoken. This is quite useful because it means you can use data sources to bring you information. Live Departure Boards is one of the National Wales projects where I can get an XML output of what trains are running on time. Funnily enough, I make use of that. Google Calendar, there is a hidden URL you can use which will download the Google Calendar to your machine, which you can then process. The weather has its own API, so you can find out what the weather's going to be like, use the voice synthesizer to tell you it is going to be sunny today, it is going to be raining. And obviously TV guides as well. And again, in XML format, you can just grab and use as you wish. So that's a lot of output things. What about some input? Well, the web is pretty much ubiquitous, you're going to have to deal with it. So this is an example of the web page I have running my home. It is quite literally a home page. And the image you can see on the left is the layout of my room. There is a light bulb, and when I click the light bulb, it sends a message to the web server. The web server connects to that little X10 unit that you saw earlier. It sends a message to the light bulb and it switches the light on. I'm sure it has a practical use, I haven't yet found one. There are other input conduits other than the web. Email is rather good. If you're the sort of person that wants to email their light switches, you can, because it's exactly the same code. As well as controlling it through the web, you can give every light in your house an email address. You can also send text messages to your light bulbs, because, well, why not? Bluetooth as well, yeah, proximity, as soon as you come in, reach your house, light switch on. And doormats. So when I leave and come into the house, my doormat sensor goes, it looks at the weather report, it says it's raining. If I haven't taken my umbrella, it says don't forget your umbrella using the speech signal. The thing on the right is a control which is connected to my computer. It's not quite waterproof. The speaker on the left is waterproof. So when I'm in the shower, I can actually control the music, see what trains are running on time, which trains are not running on time, and so on. This is basically what we've had so far, an abstraction of the input process, send it through text messages, through voice, through email, and output methods, all abstracted. The on-train button. When I get on the train, I press that button. It knows how long the train journey is. It then sends me a text message 5 minutes before I get there to wake me up. It then knows how long the taxi is from the train station home, and it puts the light on ready for me. It also knows the weather, so if it's cold, it can put heating on ahead of time. Lots of those, we all live slightly differently, these are necessary, and you can do everything that you could possibly ever imagine. I mean, one really simple idea is to get the computer to look at the calendar. It knows that I'm home. It knows my TV schedule, because it's already emailed me my TV schedule. So 10 minutes before my program is going to start, it uses
And yes, hardware hacking, it is awesome. There's no reason to laugh, seriously. You can make things. I mean, you can just go home and make things. That was me, that was why hardware hacking is awesome. I'm Alex Roach, and if you have any questions,
What was that?
I'm at TimeMaster13 on Twitter, ask away.
Thank you very much. Next, we have Margaret. Margaret's going to talk to us about All for Science and Science for All. Go, Margaret. Just give it a second for the slides to show up.
There we go. Hi, everybody. Thanks for bearing with us at the better end and staying in the way of your food and your drinks. This evening, I'm hoping to inspire you to use your skills for science. Science for all and all for science. Participating in science, actual science, starts way back in the late 1800s with volunteer wildlife monitoring. An American ornithologist asked people in a neighboring state to keep track of bird migration patterns when they arrived in the winter, when they left in the spring. And over 15 years period, he collected more than 1 million handwritten notes and telegraphed notes from ornithologists all over the U.S., which was one of the first in-depth surveys of bird migration patterns. And of course, that kind of volunteerism continues today, especially in wildlife monitoring, and has come to be known as citizen science. And that's what I'd like to tell you a little bit about. Citizen science is really starting to explode, primarily because of the computing power of computers to actually process all of this data, the power of the internet to connect us all across wide geographical areas across the globe, and the power of the web to provide us with these amazing interfaces that make it really easy to input data and engage with other people doing these kinds of real science projects. But of course, the ideal scientific device is already in our pockets. Mobile phones in the field are a superb data entry mechanism, and it can connect it to photographs and GPS data location, and also load that up to central maps, allowing citizen science to happen across the globe using the phone. And it's about way more than just wildlife monitoring. It's across all sorts of different kinds of fields. Where it really gets interesting is the accessibility of devices to people absolutely everywhere in the world. This is a citizen science project that's taking place in the deep Congo in the literate group of hunter-gatherers. And they have a GPS data device, and they have designed their own set of symbology to use on the touchscreen so that they can map their area of the deep forest, which is otherwise unmapped. And it's given them the power to put anti-poaching and anti-foresting measures into place, and allowing them to finally, for the first time, make full use of the governmental protections of their sacred lands and where they live, something that otherwise wouldn't have been possible. And they've actually designed this science project themselves. It's fully extreme citizen science is one of the catchphrases for it. Many of you are probably familiar with how computing power is getting harnessed, especially in volunteer computing projects. And one of the earliest ones is, of course, Study at Home, which was allowing people to study radio data looking for signs of extraterrestrial intelligence. And there's many more massive volunteer computing projects like this. For example, the climate.net project, which allowed people to run data prediction models on an absolutely massive scale that individual scientists would not have had the raw computing power to do. These kinds of projects are a little bit controversial as to whether or not they're citizen science, because they're not as directly participatory with the science. You often only see the outputs if the project gives you some kind of visual output. But a next generation of volunteer computing projects are currently being worked on. I'm involved in this one at CERN, which is using the Large Hadron Collider. There's a project right now called LHD at Home and Test for Theory, which is on the same point platform as Study at Home, running